Remember this. Surrection on your stuff.
I just dug up a Jabber scribe and
Huh?
I just dug up a Jabber scribe and a note taker.
Okay, and so this guy sitting here, his name I'm drawing a blank on, the guy in black. Yeah, said that he would be a Jabber scribe.
Oh, excellent.
When you come up here, this is where you'll be standing, and they want you to stay in the box so that they can put it down.
Bring me some of those. So, if you've got them, they will go to a good cause.
So I have some at my office, but I don't have any here. Somebody, I'm not sure who, brought some to Hackathon,
Yeah.
but it wasn't me.
It was you.
It wasn't me.
Okay.
Sorry, I wish I had some.
Okay, so, and you started the blue sheets, right?
Blue sheets, I started with
Yeah,
them.
they're good, good. Okay. So good afternoon. You're now in V6OPS, and I realize that everyone around us is operating on Latin America time. However, we will actually start on time. So what? Mañana. Yeah, right, okay. So, sorry?
Sound is not good.
Yeah. Okay, is this better? Dumb question, tell me about this. Is the sound good here? Look. What? Okay. Okay. So this is the agenda that we have today. I have two drafts that we have discussion on. The first one is Fernando Gont's draft, which we've actually had quite a bit of email conversation on. And I want to figure out a way forward on the topic, which may or may not be the draft. But we've demonstrated that there is in fact a problem with extension headers. That's the document that is currently in the ISG and on its way to the RFC editor. And the question is kind of, so what? And the authors are very interested in seeing this particular draft become a working group draft and become fully fleshed out. We've had opinions in that direction and opinions in a couple of very other directions in the mailing list conversation. And basically what I want to walk away with today is, so what's the way forward on extension headers? What do we as an operational group want to figure out about that? The second one is Mark Smith's issue with neighbor discovery cache exhaustion. And then we have actually a presentation about the deployment of IPv6 in Latin America, which I think will be interesting just to understand the business and the technical implications for business here in Latin America. We may have a fourth presentation in the event that we actually have time to do it, but we've only got 90 minutes today, so this is what we've got. So let me ask, does anybody want to bash the agenda? If you throw tomatoes at the screen, it's loud. Okay, nobody's bashing the agenda, that's fine. Now, what I don't have is a set of slides or a speaker for the first draft. Who is here from that author set? The author just walked in. Dr. Gaunt. So you missed what I just said, which is that we've had more than a little conversation about your draft. And I'm trying to figure out as a working group what the way forward on the topic is. So I've got you on the agenda. You haven't sent me any slides, and I'm wondering what you would like to do.
I did.
You did send slides? Let me guess, you sent them 5 minutes ago? Oh, that's 95 attendees. If I have slides from you, I don't see them. Do you have them on a stick? Yeah. You just sent them?
Yeah.
Okay.
I had sent them to the chair's pages.
Okay.
So this was the original email.
Okay.
So it was.
Here we go. Okay. Well, so come on up here. We're going to need to put you to work. And okay, so this thing has a pointer on it.
Okay.
It doesn't actually move the slides, so this one moves the slides.
Okay.
So I'm Fernando Gont. I will be presenting the ID on the operational implications of IPv6 packets with extension headers. For this presentation, I just kept only a couple of the background slides, okay? So essentially what this ID tried to do is to provide an overview of the operational and security implications of IPv6 extension headers, and try to document reasons for which some operators drop packets that contain extension headers. And this is kind of like, within the charter of this working group, where, we have to document V6 operational experience and solicit input from network operators and users to identify operational uses with IPv6 internet. And we also try to do, what we also try to do in this document is try to provide some sort of action plan that could help improve the state of affairs. So this tried to summarize the implications of extension headers. So one of the operational reasons for which sometimes these packets get dropped is that operators are trying to do things that involve learning the layer 4 information. These are some of those things. And the thing is that when it's impossible for the boxes that are operating on, that are dealing with the packets to obtain the layer 4 information, usually what they end up doing is dropping the packets, okay? Quite a few times that has to do with, limits in the devices processing the packets. For example, there are devices that can look only that deep into a packet. So let's say if the upper layer protocol is within, let's say, 16 bytes of the beginning of the packet, that could be fine. But if the upper layer protocol is farther deep into the packet, they cannot process that in hardware like fast enough. Okay, we kept that. Other reasons for which some of these packets might be dropped. I think that it's not in the majority of cases. I personally think that it's certainly not in the majority of cases, is that at times there are operators that try to apply filters, and they don't have good granularity to apply just the filters that they want to apply. An example could be, this is just an example, that they might want to filter routing header type 0, but not the other types. But maybe they can only specify filters for routing header, and regardless of the type. This is an action plan, or rather than action plan, it's like possible ideas that might help to improve the things. I think that before going through them, I think that the motivation of this document is twofold. On one hand, we have discussed a lot of times the rate at which packets with extension headers get dropped, okay? And quite a few times there has been the discussion of whether that makes sense or not, whether there's any reason for that or not, etc. So one of the things that we are trying to do here is to provide reasons for which some folks drop these packets. We're not saying that that is the desired outcome, but we're saying that folks are trying to do things, and with the devices that they have, that they don't have that many choices, okay? That's on one hand. Certainly, it's not a recommendation for doing that. I want to make that clear. It's just saying, there's folks doing that, and the reason for which they do that is the ones that we are explaining. The other one is to, try to figure out what's possible for us to do for that situation to improve to the extent that is possible. And these are some of the, ideas or some of the things that, might help. One of them is require better granularity when it comes to the specification of filtering, describing filters that apply to extension headers. The second bullet, which is work in progress already, is provide advice on the filtering of packets with extension headers. And the third one, which has been discussed a few times on the 6-month mailing list, is to try to enforce some sort of cap on the maximum length of the extension header chain. There are different options for that. I guess that one option, which probably might be harder to get consensus on, is to do it at the standards level. Whereas on the other hand, it could be more of a gentleman agreement of saying, well, I mean, right now we are pretending that we can do this, but we all know that we can't. But we don't want to formally, update the spade. So why don't we agree that, for the time being, everyone should be able to have gratefully, extension header chains that at least are this long. We're not saying that those are forbidden, but at least try to, specify something that folks that are meaning to use extension headers can expect to survive. Right now, our expectations are very high, but reality is way low. So, I mean, it's not a nice thing to do to, try to, let's say, acknowledge that that is the current state of affairs. But reality is reality, right? So I guess the comments that we would like to receive is, first of all, for folks that, let's say, might agree or might not. Also, if folks agree, we'd like to know that. And if there are any, topics in this document with which folks might not agree with, well, we'd like to hear about that. To the extent that is possible, I mean, specific topics, and if there's room for improvement, I mean, to let us know.
Okay. So, okay, I thought Bob was going to walk up to the mic. He actually walked past it.
So Eric Vink. So I like the document, right? As I said on the mailing list, it's better to try to improve the situation and let the door open for extension to IPv6 thanks to the extension header. So this is a kind of positive document. My question now, how did you get the content of this document? Do you talk to multiple service providers, or is it more like testing or guessing?
What we did, we talked with many operators, and actually, I don't know if there are 2 or 3 are part of the authors of the idea, and they represent the opinions of others. I cannot say and couldn't possibly claim that that's the the opinion of the operators, but certainly it's the opinion of a number of operators.
Did you get? I'm not on the NANOC mailing list, but did you publish this document on NANOC or RITE mailing list, for instance?
I mean, off the top of my head, I don't recall, but usually when I publish this kind of documents, you will see me forward them to the RITE mailing list, to NANOC, and so on. Yes, I usually do that.
It would be nice to get real advice there.
Okay. Seeing nobody else running to the mic, I'm going to pretend I'm standing at the mic and ask a few questions.
Okay.
One of the issues that you raised was that a hop-by-hop header can force a packet to a different path, something other than the fastest processing path. Now, that particular issue is being looked at in 6-man.
Yeah.
We can't necessarily update hardware that's already in the field, but we can affect the next version of the ASIC. So that's actually a discussion Wednesday morning.
A side comment, sorry, I fully support that document.
Yeah, okay. And yes, I'm the author, but that's not my point. Okay, I'm trying to look at the problem. Now, if I find a hop-by-hop option in the IPv6 packet and the only option that it contains is a pad, and I've got a piece of hardware that recognizing the hop-by-hop option forces it off the fastest possible path, I've got the possibility of that DDoS attack, which is the concern that you're raising. In what way does putting a cap on the maximum length of the IPv6 header fix that?
Well, what happens, not in that particular case, but what happens is that with extension headers in general, okay, if the extension header chain is short enough, they can process the packet in the fastest path. Whereas if it's long, they had to do software processing.
Okay.
So yes, it doesn't address everything, but it addresses cases in which when you have arbitrarily long extension header chains, you have to resort to software processing because you cannot do that in hardware. So what we are trying to do is let's agree that if you play with extension headers and the extension header chain is this long, well, you should be expecting for these packets to be processed fast. That doesn't necessarily, if we go that path, I don't know what would be the exact number. I guess that one possible option would be to, take a look at major platforms and say, for example, any extension header chains that are smaller than 64 bytes are okay for mostly everyone. So that would be one possible way forward, like the less common denominator, and saying, well, up to this value, it's fine. Or you're not going to have issues. Right now, that's not clear. There are some folks that did some testing, and even when you look at the extension header, when you measure the extent to which these packets get dropped, the larger the extension header chain, the higher the drop rate. So for example, if for an extension header chain of 256 or 512, no chances at all, they are dropped. For 8 bytes, the drop rate is way better. Doesn't mean that it's good or perfect, but it's way better. Now, if we can agree, like saying, well, if you move within these limits, things are not perfect, but mostly okay. Well, that's a good thing, because for the guy that wants to use the extension header, he knows that playing there, it's kind of like fine. And if you go outside of that, well, you know that you're hitting trouble. But the problem is right now that's not clear. So if you want to play with headers, it's like, well, what you assume is, well, they don't work in practice. So the thing here is try to figure out what, within with limits, we can expect things to work the way we expect them to work.
Mark?
I find it interesting that this is an operations document, an operations working group, and it sounds like you just had a long discussion about how to design an ASIC inside of a router.
Sorry?
No,
Well, I think
design
some hardware
the
designers,
hardware, not operate it.
yeah, so.
So I mean, you quickly dive, so why would we try to encode limitations or non-limitations or what have you in terms of specific hardware that exists right here and right now in an operations document?
No, what we want to make clear is that, it's if you play outside of these limits, things don't work. So rather than trying to, encode limits, what we are trying to make it openly clear is that when you go outside of those bounds, I mean, things don't work the way you expect them to work.
Illustrious AD.
I guess I'm Joel Yeagley, at least that's what the badge says. I think it's not so much that we're trying to design ASICs, it's that as operators, we have to live with the ones that we have. And so I think there is some value in making statements about those because they do exist. Now, I did realize this morning that a lot of my understanding of the way IPv6 is forwarded in routers is actually derived from my understanding of the Martini architecture, which is like state-of-the-art Juniper circa 1998. And that might actually be a little dated. So I think, yeah, perhaps you can parse a header longer than 52 bytes. But I think we're also making some assumptions that you can do that are, say, a little bit more generous and more realistic of what we have today and what we might have in the near future, which doesn't look very science fiction-y to me. I mean, Ethernet switch ASICs are like, the future looks a lot like the near present.
We do have someone in the virtual line. So, Mark Smith, can you hear you now?
Hi, how is everyone? It sometimes seems to me when these sorts of lack of consensus or back and forth go on for quite a while.
Mark, you're a bit quiet. Can you speak up a little?
Oh, okay. It seems to me sometimes when these sorts of stalemates happen that perhaps what's happening is that we might not be really using the right tool for the job. So I can think of the 2 or 3 things that people are trying to use extension headers for and think of possibly better ways or to solve those problems that don't necessarily have those limitations. So I'm just wondering if we're making this assumption that PHs are the only way to solve it, and then we're getting caught up in round and round, back and forth.
Did anybody get any of that? Yes? Could someone repeat it, because I'm looking at, I see a lot of people saying I can't understand what he said.
Yeah, it turns out, Joel Yeagley again, it turns out between the competition from the room next door and the fact that the speakers are actually somewhat further back from the edge of the room, that's hard to parse. But I think Mark was channeling the assertion that like our imagination is a bit limited, and it's currently constrained by the things that we have already done, as opposed to uses that we might actually have in the future, and we shouldn't just constrain ourselves that way.
Just to add upon that, one of our own RFCs on protocol success, RFC 5218, states pretty clearly that hard scalability bounds are bad things to build into protocols for long-term success. So while we've had some recent success in V6, the jury's still out on whether or not we're going to make it to long-term success into those things that we can't think of today because our imagination is limited, as Joel was saying. So let's not put in any hard scalability bounds into our protocols.
I'm sorry, what was your last sentence?
Not put any, or even imply that it's okay to have a hard scalability bound in protocols.
Okay.
You mean hard, as in like
Yep.
stopping?
Look it up in RFC 5218, it's well defined. A hard scalability bound is, for example, 32 bits in a V4 address, or 640K RAM in your memory architecture, or, right?
Yeah, I don't take 5281 to say that we should go crazy and go with variable length addresses, for example. So like, I mean, exactly, IPv8. I think there are definitely limits on there are places where we have limitations, and so we should be mindful of those. We should also be mindful of not being, not painting ourselves into a corner just because we happen to like this particular corner.
Well, and yet that's essentially what Fernando is talking about, is giving some advice to people saying this works and that doesn't.
Yeah, I mean, it's also helpful that we're not protocol designers, so we actually, it's not incumbent on us to take the blame for things that were done by other people. So we should take under advisement and be willing to talk about the things that we do know work. And if we have problems, we should talk about them because we're operators.
Hi, I'm Bob Hinden. So I'm mostly agreeing with what Mark and Joel said. I mean, the way I think about it is, creating limits based on way stuff works today, is going to hurt us in the future because it's, the capabilities will get better. And I also sort of think, maybe more importantly, this seems like a self-correcting problem. If people build, someone tries something out with a very long header chain and it gets very bad performance, they will probably stop. So I'm not sure it has, it's like people are going to tend to optimize what they do on the internet based on what actually works well. It's not this, they will notice that it works badly because it goes beyond what can be done in the fast path. So I'm not sure it's an actual real problem that we have to provide, strong guidance on what works, today, but might be fine in 5 years from now.
So Bob, I've heard a rumor that you actually know something about IPv6. If you were to give Fernando any advice on how to proceed with this draft, what is going to be useful commentary and what is going to not be useful? What advice would you give him?
I need to read it again before I can answer that question. Okay. But I will try to do that.
Okay. Tim?
Tim Jones. So I think the document as it stands, I agree with Eric. I think it's a good piece of work and a good summary of things that are being observed by various people. I do share the concern of putting a marker in the sand about limits of the extension header chain. But I think the first 2 points there, first 2 bullet points are certainly something that we could develop information or documents on to give people some guidance. I'd be wary on the third point of saying we shall have extension header chains. For some reason that's hard to say, to n bytes at this stage. I think that would be, I agree that would be silly.
Even with the third one, I mean, that's mentioned as an option, but I think that at least if we could note, like, when you measure stuff, up to this point, things are fine. And right now, over that, it's not fine. I think that's useful information. Even if you don't force any kind of cap at all.
I think the measurements that you and I and Jen and others have done show that as you make the header chain longer, you get less reliability in the
Yeah, the longer they
end-to-end
work,
transmission. There's no question about that. But in terms of what we can do here, I mean, the charter of this working group is to identify operational issues and produce informational or BCP guidance on how to deal with them. I think the first two things are things we can definitely do. The third one, I share the concern I'm hearing about putting a hard limit on that. Certainly we can put in this document the observation or the other document that's currently with the ISG, but I don't think we should be putting a number on it. It makes no sense.
We will be closing the mics very soon. If you might want to say something, it's a good time to stand up.
Okay, so Eric Vink again. As I said before, I kind of support this document. I just want to be clear on the first two bullets. The last one is a snapshot in time because the length will be increasing and increasing and increasing. So I consider this not really a good way to go forward. But I fully support you on providing some BCP on the first two one. Michael?
Michael Abrams. So I rethought. In the beginning, it was all, again, there was filtering instead of being dropped.
I replace everything.
Yeah, but in the presentation in the beginning,
Still?
I think we're
Well, that's
still
my fault. I
filtering.
mean,
Well,
yeah, sorry for that.
I know I keep saying this.
Yeah, sorry for that, but-
Because for me, the intent is important. To say that this, a lot of this is being done without any intent.
Yeah, whatever it says filter, it should say
Yeah.
drop. That was the intent.
Hi, Mike Ackerman. I think this is really good and really important work. As someone who wants my company to start using IPv6 in production, I think this is necessary to get these things working well, not just working, but working well, and to understand why. So support this completely, really good work. The only thing I would add to this, I think all this is good, is it out of line to say a fourth bullet that's the opposite of the third bullet and say encourage hardware vendors to process more in hardware. And maybe that's out of line for this committee because that's on the borderline of a protocol change perhaps, but that's what I'd like to see because if we put a cap on it, then our future is not bright. So, thank you.
Okay, and we'll cap the mic after Mark.
Imagine if, 15, 20 years ago or what have you, we had published there seems to be a lot of routers that only support one MPLS label. Therefore, put a cap on it, only one MPLS label. I suspect the MPLS guys would be very upset because you wouldn't have ever had MPLS VPNs. You would have never had pseudo-wires. You wouldn't have those things that required two labels, much less all the new use cases now that are 6 labels, 7 labels, for all the wonderful segment routing and loop avoidance and all these new things, because they didn't, even if there is hardware today or then that's limited, as I think it was Bob was saying, this is a self-correcting problem over time. And so I support the idea that, if operators want to give advice to vendors, it's, make things more flexible for the future rather than, hey guys, we're going to cap it so you don't have to worry about it anymore.
I don't disagree with you. So
Great.
Okay, so at this point, I want to basically figure out what guidance the working group would like to give Fernando and company. He has asked us to make this working group draft, and the discussion that I saw on the list, I saw about 3 different consensuses operating, and I need to see one. And so I don't think, based on that discussion, we can take it as a working group draft, at least not at this point. What would you like to see happen with the draft that would allow Fernando to achieve his objective and give good guidance to 6-man, to operators, wherever they might be, to vendors? What would you like to see happen?
Sorry, Fred, could you just give us a sort of a 1-sentence summary of the reasons why we might not have that vote on adopting the draft now?
I'm sorry?
I'm saying we seem to have some sort of consensus in the room that it's a good document, and the first 2 of these things are things that you could move forward with, blah, blah, blah. So what were the reasons on the list about not adopting this as a working group document? I don't follow.
Well, part of it was Bob's comment on a.
There was a request for you to speak
self-direct-
closer to the mic.
Part of the issue that was raised on the list was Bob's comment, and I think it might have even come from Bob, saying that this looked like a self-correcting problem. If it wasn't Bob, it was somebody he's sitting next to.
Tim Chan again, but my understanding of what was just said and what Mark said, I think, was that they were talking about the third bullet there, not necessarily the first two. So I think if you maybe put it to the room saying, if we progressed it and we take out the third point here,
Well, so
maybe there's more of a consensus there.
The issue there is actually an OPSEC draft, which he lists in the second bullet. And number 1 would be advice to vendors coming from that draft. And the second bullet would be advice to operators how to use those filter options. That's currently an expired draft. OPSEC has not decided to do anything with it. And I would think that that's first and foremost OPSEC's call. What do they want to do with that?
There's another part, other than the future work, is that quite a bit of this document is about what are some of the reasons for which the folks need to look at the layer 4 information. And whenever this topic is discussed, usually the answers or the stopgap there is like, oh, you shouldn't be looking at the layer 4 information, you are just forwarding packets. And I think that, all the times that we have discussed this, before actually getting to discuss that, to get to discuss the stuff that we want to discuss, we have to go and repeat these reasons that we have here. So I think that other than the future work, the reason for which these folks need to look at the layer 4 information, I think that that's valuable too.
I think I understand the frustration.
I'm frustrated with all three of these because, if we believe that we don't have the right level of imagination to understand how the extension capabilities are going to be used in the future, then how do we write better specification on the filters, right? I can understand why the first two are frustrating, because you want to filter something for a security reason or a policy reason or what have you, but at the same time, we're not sure exactly how these things are being used. So they're kind of at odds at one another. And of course, the third one, to be clear, that's my point earlier. I think it's a very bad idea to suggest a particular, number of bytes is to enforce it based on the fact that ASICs can do this or that. The other two, maybe, but I can see how they're frustrating because we don't know exactly how they're going to be used.
So Ole Tran, I've written all my comments in the minutes already, so you can see them there. But so I'm, as I said on the mailing list, I'm not in favor of this draft at all, largely because it's making policy on how protocols should be used, and I don't think that's IETF's business. There are many different networks, not only the internet, that use the IPv6 protocols, and I don't think it's there is not going to be a consensus among all network operators on the planet and end users and vendors. This is a tussle of which policy you want to apply to packets. Some networks filter UDP port X and some throttle them and some don't. There's very little IETF can say about that or should say about that. So I think this doesn't really make very much sense to standardize because it is policy.
But here we're not trying to, push any specific policy, but actually on the other hand, or on the contrary, what we're trying to do is to allow people to enforce whatever policy they want to enforce. So what we're saying here is that with the way things are right now, you cannot really enforce the policy that you may want to enforce.
I also think it is somewhat of a paradox that we have one IETF working group that
writes protocol specifications, and then we have another IETF working group that puts out recommendations on how you should make those protocols not work.
Christian Wittmer from Microsoft. I certainly agree with everything that's been said about not doing anything as a cap on maximum length. My reservation with this draft is that it seems to be a license to drop packets.
License to drop.
A license
Oh,
to
yeah,
drop
it's
packets.
license to drop packets, yes.
As in, oh, we told you to do that and you did not, so I can drop your packet. And as such, this kind of stuff can do a lot of harm very quickly.
Okay.
Tim Chang, just in response, I think, to what Uli was saying, is I think there's a number of examples of things we've produced in this working group which are not prescribing. They're informational documents suggesting how you might manage traffic, things like simple security, for example, which have been quite contentious, how you filter V6 traffic, for example, for CPEs. But we've come to a consensus on publishing something that a number of operators are using. So I think there's counterexamples to what Uli is saying.
Lee Howard, operator hat. It seems to me this is a working group where we can provide recommendations. If you have a network, if I have a network, and I do, that I occasionally want to drop packets to protect my network, there may be good reasons for dropping packets, like my routers fall over when they get packets formed a certain way, which is exactly the kind of example we're using here. So recommendation for how to handle packets that my routers can't handle is exactly, I would think, the sort of guidance that I'd be looking for. We can make a recommendation for if you want to filter certain kinds of ICMP packets, then here are the kinds that you should not filter, or things will break, right, and provide recommendations. But operational guidance is clearly in scope, and sometimes there are packets you don't want to receive. So that seems like reasonable recommendations. Whether we know what those recommendations should be, I haven't seen yet. I don't think I'm not sure we yet know what to recommend. Yes.
So lead, don't go, because I had a comment to you. So are you actually proposing then, because I've spoken to some of the operators that do filter extension headers, and one of the reasons given was that there's a certain firewall that crashes if it sees a certain combination of extension headers. And they remove those filters because that firewall, when I asked them, because that firewall was, disbanded years ago. Are you suggesting that the IETF then should write documents essentially countering vendor bugs? That seems like a very difficult thing to do, and they will be outdated before they're published, right? The bug got fixed, so there's no point doing that filter anymore. Well, you can if you want to.
So no, I'm saying we should filter vendors who have bugs. No, I thought. So no, so obviously, okay. So your point is arbitrarily long extension headers are syntactically valid and therefore should be accepted.
It wasn't particularly
Okay. So just so if it's a correctly formed packet, see, I guess part of it is if you're sending a packet that's destined for my network, if it's transiting, all right, that there may be a different argument there. But if it's destined for a host that I manage on my network, then I may want to drop it based on. I'm trying to think of an example of an extension header that I would say, I don't want to use your hop-by-hop options.
Well, we certainly have implementations from the past that would basically follow if you gave them a hop-by-hop header, right? But does that mean that forever now, because we made a mistake in the past, that the IETF now recommends that you should never have these type of packets? I mean, that's silly, right?
I think there's a difference that we're talking about between a hardware failure and a policy decision. So another possible option would be to ignore extension headers if I don't like the extension headers in a given packet. So that would be another fair recommendation. And all I'm saying is, it is reasonable for us to make recommendations to network operators.
So if 6man were to make a recommendation that extension headers could be ignored, that you simply step past things you don't recognize or whatever. That would be sufficient for your purposes?
I would, would it be, yeah, probably. So, I mean, and I'm not sure that's even a six-man scope, but I mean, in general,
Actually, it
yes,
is.
ignore headers you don't understand.
Yeah,
Ignore
well,
fields you don't
so
understand.
there is a specification in 2460 that says if you don't understand it, you
Right.
should drop it. And suppose that got reversed. Suppose it said if you don't understand it, that ignore it.
So it's RFC 7045? Okay. So, yeah, off the top of my head from the microphone, I'm not sure.
Okay.
What I was trying to get back to was, we don't have to necessarily say, this isn't, I think what I was trying to get at is there's not a binary decision between never use extension headers. No, we're allowed to say something about what to do with packets with extension headers. And there may be useful guidance. I don't think we have consensus of what that guidance is yet. But I think but I don't want to say, well, we can never recommend dropping a packet, because obviously we can recommend dropping a packet.
So a comment and clarification to provide background for this is that when we published the other document with the measurements that show like a very high packet drop rate, the reaction in most cases was like, well, these people are all crazy. They are dropping these packets, and why the hell they are doing that, right? So it was assumed that the reason for which we had such a high packet drop rate was because of operators' fault, okay? So we published the measurements, split, the reasoning with the results. And what we have here is like, well, there might be people that are dropping packets because they don't know what they are doing, but there are certainly folks that are dropping packets because they actually know what they are doing. So this is what this document is saying. It doesn't say you should do this. It doesn't say you should drop packets. It's saying, well, right now you're seeing this in the network because this is the problem that is being faced. And as a result, these people, the only option that they have is to drop these packets. And that's, besides the future work, it's kind of like explanation of why we see what we see. And I think that's useful, because if we just keep the results like, well, the results are bad, but this is because all these people, they don't know what they do, that's kind of like hand-waving. This is like saying, well, there's actually a reason for which these people do this. If we agree on the reason, we understand what's going on here, we might have a chance, to improve things and move forward. But if we just, ignore the reason for which these people drop the packets, we'll never get to a better status.
Now I'm back to chair hat on to say, looking for consensus in the working group on, is this, as it stands, useful information, or is there further guidance, either one of these things, or is there more that needs to happen with the document before the working group wants to accept it? So pretend that was said from the table.
Why did we separate the reasons from the results?
Because when we did the measurements, we were just inferring stuff. I mean, we measured. We didn't ask people by people, like, why are you dropping the packets? So that was like a snapshot of what is going on. And even here, obviously, you cannot...
And so is this. This is a snapshot of a guess based upon some measurement.
No, it's not a guess. It's talking to operators that are known to drop packets, and they say, this is the reason for which we drop them. There might be other folks dropping packets because they don't know, because of bugs, because of whatever, but there are certainly folks that drop packets because of this. So this explains the intentional drops.
Are you sure? Because...
Well, okay.
Okay.
I need to bring this discussion to close. We have 2 more agenda items, and we've gone through half of our time. So I'm going to have to take it to the list. We're not getting to closure here today. What I think we can say is that we do not see consensus in the room or on the list to actually make it a working group item. The guidance that you've been given today is really think in terms not of limits, but of things that you'd like to see supported. Encourage vendors to make their gulps deeper, and that kind of thing. But I think we're going to have to take it to the list at this point. So, okay, thank you. Sure. And Mark? What did I just do? I just did the wrong one, right? No, here it is. Mark, you're on Meet Echo, right? He was earlier. Okay, I'm going to suggest that we come back to Mark. He has stepped out of the room. Sorry?
So yeah, I see Mark on the Jabber room. I don't see him talking on Meet Echo. I did press the button to unmute, and then I pressed it again to unmute, and I can press it a third time to unmute. Mute. Yes, Mark.
If you type Meet Echo in the Jabber room, it's a bit like Beetlejuice. The Meet Echo people appear to help.
It is 3 o'clock in the morning. Okay, here's what I would suggest we do. Let's go ahead with the LACNIC presentation and then bring Mark back in after this is started. No. So this is a little complicated. This thing will give you a plan, but it won't advance slides. This one advances slides.
Hello. Good afternoon. Thank you for letting me present here this project that we have done in LACNIC. This is a study we did last year, second half of last year, about the IPv6 deployment state in Latin American and the Caribbean region. I will. It's a big study, a big project, and it has many parts. I will only show you some of the main facts we identified. I will like to show you some interesting conclusions from that study. This is a study that we did in partnership with Banco CAF. Banco CAF is the development bank of Latin America, and they provided funding for this study to be done. The idea of the study is to understand why this region is still not adopting IPv6 and why the adoption rate is still low compared with other regions, and what can we do to improve that situation. The results are published at that address, portal ipv6.latnic.net. As I said, the study includes several parts. There's a survey we did among all the members of LACNIC, asking them reasons why they had deployed or they are not deploying IPv6. One of the main parts of the study were face-to-face interviews with the largest ISPs in the region, with governments and academic institutions. There are also a large number of guides, recommendations, and best practices. And also we worked in an economic model for helping the ISPs evaluate the cost of the different alternatives. We included different point of view from ISPs and content providers, mainly, but also from governments and academic institutions or academic and research networks, because we think that those organizations are drivers for IPv6 deployment. So we were interested in knowing about their plans. And there's a detailed analysis of the successful stories, the successful organizations that deployed IPv6 integration. That is a small number, but we will be talking about that. In this process, we define an indicator which we call LACNIC ICAV6 or ICA V6. which is based in works done by other organizations like Cisco, Akamai, Google, or Apenic, and others. We use the indicators they provide, and based on that, we define an indicator of a progress, a development progress indicator for the region that is that give us a quick view of the state of advance in the different countries and permits to compare that with other economies. It's very similar to work that Cisco has done, like the indicator that Cisco provides. But in our case, we gave more weight to the initial phases, to the planning stages, because we think that here in Latin America, the countries have still not developed IPv6, has not deployed IPv6. So we think that we give more weight to the, even more weight to the planning stages. We can compare the different countries. This is based on some partial indicators that you already probably know, that are the percentage of IPv6 allocated prefixes with observed traffic. This is one of the indicators we use. The other one is the autonomous systems that provide IPv6 transit. The other indicator is content, which is the weighted percentage of IPv6 enabled sites. And finally, the users, which is the percentage of IPv6 capable end users. With these partial indicators, we define this number that is here. Which gives 30% of weight to the what we call the planning stages. That is that the ISPs prepare themselves for giving transit in IPv6, or they are with some IPv6 prefix advertised to the global routing tables, and that prefix has some amount of traffic. And we give a 70% of weight to the product of content and users, that it's the main indicator of traffic. It's a good estimate of traffic. And this is done in such a way that only countries that deploy IPv6 to the end users can have a value higher than 30%. Here we have, as I said, this is a quick view to compare the different countries. You can see here, from here is Argentina, and here is Venezuela. All those are the Latin American countries, and those here are other countries in the developer world. So the idea of this quick comparison is to see, for instance, that even there are some countries like Belgium that are leading the IPv6 deployment in the world. There are some countries in Latin America that are not so bad, like this and this, which are Ecuador and Peru, and the others are below the 30% limit that I mentioned. Well, I think this is, you are not going to see this, but this is the global LACNIC ICA V6 indicator and the partial indicators. And this was a previous analysis we done before doing the actual face-to-face interviews. And from here, what we learned was, for instance, that some of the the only 4 countries that were deploying IPv6 to the end user were just the 2 countries that have this column with a different number, which is not 0. If you look at this column, most of the numbers there are 0, and only Bolivia, Brazil, Peru, and Ecuador are the countries that are deploying IPv6 to end users. With respect to other indicators, for instance, the transit IPv6 the autonomous systems that gives transit IPv6 are more or less the same in the main economies of the region, so that's not a problem. The content is almost about 50% in all the countries, and that is related to the fact that the content is weighted by the number of visits and the traffic from that site. So this number, which is 50%, is related to the fact that from all of our countries, we go to all the same sites like Google, YouTube, the CDNs, Netflix, and so, and those are IPv6 enabled sites. So the main conclusion from this analysis is that only 4 countries are deploying IPv6 to end users, and that was confirmed in the field study we did. We went to 10 countries. We took a sample of 10 countries in the region. The countries were Argentina, Chile, Bolivia, Peru, Ecuador, Colombia, Venezuela, Panama, Dominican Republic, and Trinidad and Tobago. We did face-to-face interview with mainly with the ISPs, but as I mentioned before, with academic organizations and governments. From there, we can identify at least 3 success models that we studied in detail. One is Comteco in Bolivia, which is a small cooperative in Cochabamba. They started planning IPv6 in 2010. They advertised their prefix in 2013, and they had, by that time, they had problems with some core infrastructure. They detected that they could advertise the prefix, but they had some equipment in the core that was not capable of supporting IPv6. By that time, they were also tendering for new equipment, so they could ask for in the tender for IPv6 support in all the equipment. So 1 year after that, they began deploying IPv6 to end users. They started in 2014, and by end of 2014, they had 4,000 of IPv6 users, and by the end of 2015, they had 20,000 IPv6 users, which is about 40% of their user base. And one interesting fact is that they had potentially more users because they have deployed the CPEs to the end users, which are IPv6 ready CPEs, but those users are still not receiving IPv6 for other reasons. But that could mean that in the next future, that situation will change. Some key facts. This is a graph from Akamai of the increasing. As you can see, the traffic has been growing steadily. Most of the traffic is video. They have 2 gigabits per second of IPv6 traffic. They detected that most of devices are smartphones, smart TVs, or on Windows 7 and Windows 8. They reported some problems with different operating systems behavior with respect to the HTTP 6 and Slack. Some sites not supporting IPv6, like Skype and other video sites. And they are not using carrier grade NAT. They still have IPv4 addresses, and they think they have at least until 2017 addresses available. The other successful model is Telefónica in Peru. Telefónica identified in 2008 that they will have a shortage in addresses because of the high rate of DSL customers, and they started planning involving all areas of the company, and this was a good move they have done because involving different areas solve some problems that other ISPs are facing now. Because in most of the ISPs, the IPv6 deployment starts in the engineering areas, and it doesn't involve the other areas. And for instance, there are a lot of ISPs in the region that have all the engineering part ready to deploy IPv6, but to the end users, but the software systems or the business systems don't support IPv6. Well, they started in 2012 the ADCL IPv6 service, and they are planning to deploy in HFC networks during this year and in mobile in the next year. This is a different situation that we faced before. We presented before with Comteco. Telefonica is doing carrier grade NAT, and they are offering dual stack to the end users with native IPv6 and carrier grade NAT for IPv4. Some users get public IPs, for instance, the corporate users, and some DSL users because of some problems the users have. So when the user complains, they give to the user a public IP. And well, they didn't have any remarkable problem. The provisioning system, for instance, and the business system were part of the initial plan, and that was a very important part. The other successful model is one of the CNTs. CNT is a national company in Ecuador, and the decision here to deploy IPv6 was driven by an agreement with the ICT ministry to increase fixed and mobile internet coverage in the country. So this company had a very fast growth rate. They had 6 million fixed users and approximately 800,000 mobiles. They started also in 2012 the IPv6 deployment in the fixed network. They are also doing dual stack with carrier grade NAT for IPv4 address sharing. They also had a high replacement rate of CPEs, so they also have more CPEs, IPv6 enabled CPEs than IPv6 ready customers, and the CPEs are prepared to have IPv6 configured.
So let me ask at this point, what's the difference between a V6 enabled CPE and a V6 ready customer? What makes them not ready?
There are some problems that maybe, for instance, the BRAS or other equipment that don't still support IPv6 in the network, in the backbone
So
of
the issue is in the ISP.
Yes, it's in the ISP, but the customer has an equipment that is prepared. Well, they also didn't notice any problems that are important to mention. And Brazil was not initially part of our study. We didn't get we didn't go there, and we didn't have a face-to-face interview with the ISPs. But in the second semester of last year, IPv6 uptake was increasing steadily, and there are two operators that are the main IPv6 enabled operators in the country: Claro Net and Vivo GVT or GVT. Those are the two main the two IPv6 enabled operators. There are others that are still in the previous phases. They are implementing IPv6 in their with partial deployments, but they are still not. The others are still not offering IPv6 to end users. And one important fact here is that there are some content providers, like big content providers like Globo and UOL, that have deployed IPv6. This is a very different situation than other countries. Also, the main transition technology is carrier grade NAT and dual stack with native IPv6. And well, there were some problems they found with prefix delegation not working in some CPEs, some CMTS not supporting IPv6, and a long testing time of CPEs because of the problems they had. And this is something that many ISPs or many operators have told to us, that they had long testing times of equipment, and this is one of the delaying factors to deploy IPv6. Other countries that
at this point, yeah, I still want to give Mark an opportunity to get in, and so in the interest of time, can you skip to your recommendations, your conclusions, and talk through them?
Okay. Well, the main findings are one of them is that most ISPs are not offering IPv6 to end users. Most have IPv6 deployed in a network core. The transition technique almost adopted is dual stack with native IPv6 and private IPv4 with CGN. And almost no operator is expecting to deploy other transition strategies like NAT64, 464XLAT, or MAP. Not even in data centers. There are operators that are deploying new IPv6 now, new data centers, and they are not deploying IPv6 only data centers, for instance. They are not using 464XLAT in the mobile. And well, countries with large internet penetration are the most delayed in IPv6 adoption. The main roadblocks we identified are that fact that the CPEs IPv6 ready are not so IPv6 ready. The provisioning system and internal business software were the most mentioned problem, and was the problem that was the most difficult to solve problem. There are some operators that are ready to deploy massive IPv6, but they can't because of the provisioning system, for instance. Well, operations or help desk training was not a big issue, was mentioned as an issue, but they can solve by themselves. With respect to universities and national research networks, IPv6 is almost deployed in the national research networks, but only to the CPE of the university. And internally, the universities are not deploying or configuring the Wi-Fi equipment or the firewalls, or those equipment don't support IPv6. And with respect to government, we are seeing that the government portals or community Wi-Fi networks are not supporting IPv6. The government are not taking that into account. We are working with them. Finally, this is just for you to be aware of. We were working in an economic model for evaluating the cost of different alternatives. We think that this is something that will be of value for the ISPs to have an economic model. We choose 3 alternatives. One with the main use in the region, which is dual stack and carrier NAT. The other is deploying only carrier NAT, and the third is buying addresses from secondary markets. Well, this is a configurable model. There's a lot of parameters here that that an ISP can change, and so we estimate the net present value of the next 5 years. Well, that's all I have to present. Is the link is there where all the information is. Thanks, and if you have questions or
Okay, Barbara?
Barbara Stark, is this on? AT&T. You said the CPE were not IPv6 ready. I saw Tim about to walk out the door. By that, do you mean that do you know whether they used the UNHIOL IPv6 ready tool for CE routers and they passed it, but they were bad? Do you know if they tried to comply with RFC? Oh gosh, what's that number now?
6204, I believe.
Yeah, that's the one. Or did they try none of the above and they just weren't ready?
no. When they said that the IPv6 was not IPv6 ready, is because when they did the testing in the labs mainly, but also they have done tests in some users they choose. Not all the features are supported. So, for instance, prefix delegation or some combination of configurations don't work. And so they had to update the firmware, for instance, and do some changes to the equipment to get that same equipment to be ready. But if they deploy IPv6 to the end user with that equipment, that will not function.
This is Tim Winters from the UNHIOL. So two things about this. One is we've seen a lot more CPEs coming into the lab, and in particular for Brazil. This has been a change. So I think they woke up to the problem of V6 ready didn't actually work. So they have a requirement now to get the logo. And to be clear, a lot of them didn't support 7084 RFC functions. So this is something that we've seen a sea change at the IOL more recently, and in particular, probably in the last 3 months, we've got a lot of panic calls from CPE vendors. So we are seeing the change. Obviously, we test all those features, including things like prefix delegation, but the logo is relatively new, so it's just something to keep in mind.
Okay, thank you. And Barbara, are you waiting for one more turn? Okay, so thank you very much.
Okay,
and
thank you.
let's give Mark an opportunity. Thank you.
This looks promising. Mark Smith speaking, says the screen.
Hello.
Gee, if I could only hear him.
Yeah, I'm saying something. Hello, how are you? Hello, this is Australia calling from a Telstrad from many years ago. Sounds.
Okay, so we need to increase the volume.
Right.
Try some more, Mark.
Hello, I'll start. So, so the abstract of my draft is for each of the IPv6 unicast or anycast addresses, nodes join a solicited node multicast group. Well, I'm using 24 bits of the address. Or I could sing Actually, you know, I probably shouldn't. This is looking dangerous. How do I advance the slides?
You can hear him on speaker.
Okay.
But you won't be able to hear him up there because he's speaking.
Oh, it's very hard to speak and say something when you can't think of anything to say.
So go on.
Yeah, we can hear you, Mark.
Oh, okay. How do I advance the slides? Oh, somebody can do it for me. Okay, so the problem is the well-known neighbour discovery cache resource exhaustion attack. People certainly spent some time on this one. I have thought about it a bit more because I really like the idea of simple large subnets. And I was thinking about a node registration would, if you like, be the way to fundamentally stop a remote attacker being able to consume your resources. But of course, we need a registration protocol. DHCP won't do it. So I was looking for things that we already had. And one of the things that occurred to me was the solicited node multicast group membership. I think next slide, if we can. Okay, yeah, so next slide again. I've got my step here, so. So yeah, problem, oh, sorry, so the proposal is to use the node, solicitor node multicast group membership to reduce and try to make it harder to find the neighbor, the router's exploitable neighbor cache resources. So just briefly, just to familiarise, nodes join solicitor node multicast groups, which are formed by appending the lower 24 bits of the IPv6 unicast or anycast address to that multicast prefix. And they announce their membership using MLD v1 or v2, and it's a requirement. The probably main use of it has been to inform MLD snooping switches of multicast present so they don't have to flood. So if a solicitor node multicast group is not present on the link, well, that indicates that there's no corresponding IDs for that solicitor node multicast group. So there doesn't seem to be much point in performing a neighbour solicitation for an address that maps to a solicited node multicast group. Okay, hang on. I've just been asked to disable video. See how we go. Right, so next slide. Okay, next slide, someone. Or I can go on myself. Right, so the method, a router collects the on-link present solicitor node multicast groups via MLD version 1 or 2. If a packet with an unresolved destination address arrives, the solicitor node multicast group for that unresolved address is calculated. The calculated SNMG is compared with the list of on-link ones. If it's present, perform a neighbour discovery. If not, we drop it and we've further mitigated a possible denial of service attack. So the question of MLD reliability came up. Lorenzo raised that. I broadly, from one perspective, say, well, if MLD is unreliable, then a lot of other things are probably not either. But I think there's probably, it's fair to have a more tolerant mode. So there's the strict mitigation mode, which is really what was on the previous slide, where if there's no solicited node multicast groups, then you just drop the packets that match to the absent ones. But a more relaxed mode would be to look for the signs that a denial of service attack is happening, such as lots of fast neighbour discoveries or lots of consumption of the neighbour cache, and only then would you drop packets that trigger neighbour solicitations. So at least this is, in this sense, while it is penalising some of the nodes, it's not penalising all of the nodes in a relaxed mitigation mode. So on the next slide, we've got a bit of a survey of devices that are doing announcing addresses via MLD, and quite a lot do. I did the Linux and Windows research. Mark Fry and Fred Baker did some Apple devices for me. About the only device that I'm aware of that doesn't actually send them is OpenBHD, according to a presentation that a few people have written. Some of them might be in the room. So it's fairly widely acted on and supported. So it sort of, I think, means there's a good success, a good chance of success of this method. But we have relaxed mitigation mode to cover the case that doesn't. So some limitations, which is the next slide. So this is quite coarse and low resolution. 2 to the power of 40 addresses maps to each of the solicited node multicast groups. And so if an attacker can guess or discover one of the on-link solicited node multicast groups, they then can still consume ND cache resources. 2 to the 40 is certainly a large number. So this is about improving things. One of the advantages of privacy addresses and or the stable opaque IIDs is that the IIDs are random, and that mitigates guessing because of the randomness of the groups. The other thing about it is that discovery is only really possible if the attacker is blind to the success of the attack, and with at least a /104 or shorter, so /64 typically, there are 16 million possible solicited node multicast groups, and that's where I think it's sort of showing its value, if you like. So next slide. Certainly, it's not perfect, but it's quite a simple thing, I would think, from an implementation perspective. It's really just adding that in, the collection of the solicited node multicast groups, and that step of calculating it, the solicited node multicast group before you do a neighbour discovery. So it could be useful in addition to 6583. Next steps, which is the next slide. So my current thinking, I've only recently been thinking a bit about this. I wanted to sort of flesh out the idea. I'm going to look at modifying the Linux kernel and using PIM6SD or MRD6 to collect the solicited node multicast groups. Any suggestions on that would be appreciated. I'm not necessarily seeking working group adoption, but if people think this is worthwhile and it proves to be worthwhile, certainly quite happy with that. And the final slide is some other thoughts I've had while working on this. Hosts could implement this if they chose to participate in MLD as though they were a router. In that case, the ND cache attacker would be a user on a multi-user host, and this would be a denial of service attack on the other users of the host. May or may not be useful depending on scenario, but it could be implemented on a host. MLD-v2 does not suppress reports, and therefore you could use the link local address, the link local source addresses of all those MLD-v2 reports to enumerate all unlinked nodes link local addresses, which could be useful for Fernando's tools or other people's tools. And finally, a further thought relating to the address registration idea. You could doctor up a rough and ready one by then having the router, once it's collected linked local sources, querying nodes if they support the node information queries or inverse ND. And actually discovered from the Apple captures that they actually support node information queries, it seems. They're registering the multicast addresses for them. So that's it. Any questions?
Hi, Mark. This is Eric Venk here.
Hi, Eric.
There is one maybe potential issue that I know that routers and switches do not participate, do not listen on MLD for those solicited node multicast group because there are way too many of them. So I'm not sure how much it impacts your idea on this one.
Well, I mean, I suppose if they would, they're actively ignoring those. I haven't been able to find anywhere in any of the RFCs that says that's acceptable. So there's the trade-off. You know, you get potentially better denial of service attack protection at the cost of now tracking solicited node multicast groups on routers.
Okay, thank you for your reply. I was completely unable to understand any word you said, thanks to the acoustic here, but thank you for your reply anyway.
All right.
Yeah, this is Dave Taylor. The audio was cutting in and out, but I thought the slides were actually very clear. So I understood all of the intent. The some other thought slide is the only one that I think is actually hard to follow. But up until this point, I thought it was actually a really good presentation and really good things to think about. There might be some potentials there, especially if you have a router or a switch that's intended for a network that may not have a large number of nodes on it, like a home router or something. It may be very applicable to doing preventing DOS attacks and things like that. So I think it's good work. So thank you, Mark.
Okay, thanks, Dave.
So, Ole Trond, just a comment. We're about to end here, I think. I'm a little concerned about building state, you know, piggybacking on a protocol that isn't necessarily designed for that purpose. So I have some concerns there. On the other hand, you know, lots of middle boxes build state out of the HTTP exchanges and ND exchanges that they're just looking at on the wire. Have you looked at the stuff going on in Savi? Because I think they came up with similar solutions. We also had, you know, explicit address registration proposals in 6-man that Eric Nordmark proposed with the efficient ND work that, you know, would also be a way of solving this, I think. So there are certainly many alternatives, I think.
Yeah. Yeah, look, I haven't all that thoroughly looked at Savi. From memory, and certainly correct me if I'm wrong, it seemed to be a bit about switches more than routers.
Okay, so we've reached the end of the time allotted for this meeting, so I need to draw this to a close. Thank you very much, Mark. Talking with Bob, since you're changing address bits, changing something in a protocol, this is probably more appropriate to 6-man than V6OPS. And that might be the next step to take it someplace, is to go talk to 6-man. So with that, I think we're adjourned. Thank you.